Hello, this is Lavneet from Clomotech. I am going to do a series of videos that are hands-on training for some concepts in C programming language. Those concepts which I find are difficult to grasp, especially by the novice programmers. For example, the usage of pointers and pointer to pointers, dynamic memory allocation, some data structure implementation. We'll do all that hands-on. And then combining all this knowledge, we will try to implement a real world scenario so that we can cement our understanding. So, today we will cover some aspects of dynamic memory management and how do we manage the memory allocation and freeing up of the memory using pointers. The idea is that we are able to understand what is the real picture of the memory for the program that is running. Actually, that is the key thing. If we are able to clearly see in our mind or clearly draw the picture of a snapshot at a particular point of program execution about the memory of the program, we can understand it very, very easily. So let me draw on this page the snapshot of the memory. So before we execute any program, by default we know that the program will have memory split into at least two parts. One is the stack memory and the other one is the dynamic memory. So let's draw that. The stack memory will be used by the program for allocation of the variables and other objects on the stack. And heap memory is coming into picture when we as a programmer call the API to allocate memory on the heap. So these two things are what we are going to be clearly talking about in our exercise. So as we do our coding and as we run our program, we will continue to come back to this picture to see what is the state of the memory of the program. So the goal is that this state of the picture or this picture of the state is very, very clear in our minds. That is the goal. So what are we going to do in today's exercise? We'll create a project and try to read some data of student objects. So here is the file from where we will read. It has got ID, the CGPA and the name of the student. We'll read this data into some objects of a structure and then we'll see how do we manage these structures using memory. Okay, so to begin with, let's create a project in Visual Studio. I'm creating a C++ console application and we create this project, and once this project gets created we basically actually delete all the default files, change some settings and add .c files because what we are interested in is not C++ code but the C code. So we delete all these files that are generated by default. Delete, and we add new item. Let's say it is source.c. Also we add a header file. All right, now we go to this project properties and change this setting of C plus under C++ precompiled headers use. We don't want to use any precompiled headers for the sake of our simple non-professional program. So we just set it to that. Now in the header file, let's create a structure. Type def struct. So for our student structure, we have um, the name, so that is a char star, the CGPA and the ID. So long int is the ID and float is the CGPA. Alright, so that's enough for the header file. When we come back to the source file, we include some default standard io.h and include standard lib.h header files and also include the header.h that we have for our program. And let's put a main function. So first thing we need to do is we need to read the data from the file. So let's open that using fopen more safer version. So the file is lying in C training C and students.txt. In the read mode, we need to just open the file in the read mode. And once it is open, we will read the data into the data structure students. So let's write a function that returns a pointer to student structure, pointer to student, get student data fp, and let's write this function student. It returns a pointer to student type, get student data. It accepts a file pointer, and then we can just start reading the data. If so, first is the ID. So what we will do is f long ID char name. Let's assume the size of the name is 100 characters at max, and float CGPA fscamp percent long d integer and ID, and then we will see if we have file end of file of the file pointer. If it is reached the end of the file, we will return null simply. Otherwise, we continue to scan, continue to read from the file. After the ID, we read CGPA percent %f and CGPA, and then we read the character that is um, space character after the CGPA, and just ignore that. So I'm talking about this highlighted character. So after that, we can get the string get s. So we read it into the name buffer. Max count is 100 and file stream is our file pointer. So this reads the data. Excuse me. And now we will allocate a student object on heap memory and fill up this data in that object. So we create a student pointer, malloc size of student object, and we need only single student object, and we need to cast it to student star because malloc returns void star. After this is done, we just need to fill up the data. Sorry, one more thing for the name, because student structure contains only a char star. It is not having an array of characters. It is just a pointer variable. So that means we need to allocate memory to this pointer variable as well, so that it can point to a memory which can contain the name, actual name characters. Okay. So ps name equals to char star malloc, and we already have read the size, read the name from the file, so we know its length, and we can say size of char into a string length of name, and we just add +1 to it so that it can store the new line character. One more thing is that at the end of this name reading, there will be a new line character after every line. So the new line character will also come into picture here. So at the point of new line character, once we read the data, we will put a null character so that the new line character is taken away. So let's do that. Once we have the memory allocation done, we copy the name that we read from the file into ps name. So string copy ps name is our target, and name is our um, source. So ps name string length name equals to null. So we need to put a null character at the end of the name which overrides the new line character so that we can get the um, only the name in the display or in the field. Once we do that, we get the rest of the fields. ps cgpa equals to cgpa, and then ps id equals to id, and then we just return this ps object. So this is how we read it. So let's try if it works fine. Let's check that out. We start using building it. There are some errors. Let's fix those errors. Okay, so we just need to use the safer versions of scam functions underscore s underscore s. Hopefully it builds fine now. We do F10, and we are into our debug mode. So we read the file. It has no null pointer. We go inside this function. It reads, it causes some exception. Let me fix that first. I'll fix it and come back so that we don't waste time on our video. And then I'll explain what is the reason behind the issue. So the issue was that we were not passing the file pointer to the scan function, so it was not able to read it. So let's try that now again. Then and F11, now it is able to read it. CGPA we read, and the name we read, and now you can see here that there is a new line character after the name, so we need to get rid of this. So we allocate enough memory, copy the string, and then we place null character, and the name should be null, but looks like we need to put a -1 over here. So let's do that, and F10, and let's set it back to here. Now it's good. PS name is good without new line character, and we return the student over here. So we can see the pointer has come filled up with the object. Now this PS object is properly filled. So at this point, what is our state of the memory? So let's go back to our diagram and draw. So on the heap we allocated a memory of student object with name, ID, and CGPA, and on the left side on the stack we have a variable name called PS, which is pointing to this. So this is the state of our memory. We have reached to the end of this code. Now because this is the end of the program, we need to put it in a loop. So let's do that. This is going fine till now. So we say that while not file end of file fp till the end of the file, we read the student data. All right. So now we can read till the end, but what happens in this case is, in the first iteration, this PS variable will point to the first object that got allocated on the heap memory. When it comes back in the second iteration, the previous PS is gone because its scope is within this brackets. So we get another PS, though the variable name is same, but it has got a different address. It's a different variable. So in the next iteration, we again get a object of student type allocated. It is of student type, and this is another PS. Its name is same, but the variable is same, different. Now we have lost the previous PS. So we have lost this. This is gone. So there is no way we can have pointer back to this object, because the only pointer, this pointer that we were having, that was pointing to that object on the heap, is gone. So we lose this pointer. So similarly, in each iteration we are losing this map pointer, but we are not freeing this memory, so this memory is lost, or you can say it is leaked, because the operating system is thinking that we are using this memory, but in our program we don't have a pointer to this memory, so there is no way we can reach to that object. That is how it is lost or leaked. So how do we fix it? So what we do is we create another data structure in the heap, which we can use to keep track of all the student objects that get allocated. So let's assume, let's draw that. Um, so I just shift this side so that I can draw it properly, and I delete this also. So let's draw another data structure, which is a memory chunk pointing to individual allocated objects. So it is a array of student pointers. But make sure that you know this, it is also on the heap memory. This is on heap. So what we do is we allocate in chunks. So it is, let's say, 1, 2, 3, 4, 5. So let's keep it 5. Okay. So this is one chunk we allocate in one go. 5, the size of this memory is equal to the is enough to accommodate 5 student pointers. So the size is student pointer size into 5. And because this is again a memory, we need to keep a pointer on the stack side to on this. So we have a pointer to this array. So this pointer is pointing to this array, the first element of the array, and then because it is contiguous, we can go to the next and so on. So what is the type of this P array type? The type of each of these pointers is student star because they are pointing to the student type objects. So therefore, because this pointer is pointing to student star, the type of this is student star star. So it's a pointer to pointer. It is a pointer to array of pointers of student objects. Okay. So how this arrangement solves our problem? So when we come in the first iteration, this object is read. In the first iteration, this object is filled up with the data from the file. The address or the pointer of this object is placed here. Yes, let's say 1. Okay. And then in the next iteration, second data is read. Second data is read and the object is filled, ID and CGPA. And the pointer of this is placed in the second um, index second element of the student star pointer, and so on, so on. So the question is, this is how we manage. The question is, what if the data, the number of those records that we are reading from the file is more than 5? For example, in our case, it is more than 8, more than 5, which is it is 8, which is more than 5. How do we handle that situation? Now, what we do is we keep the scheme the same, but we increase the size of this chunk to be more. So we took example of in our example a chunk size of 5. So we are allocating at one go 5. We can decide any chunk size and we can again allocate more using realloc function and copy this data to the new memory, the existing data, and we are ready to use the remaining new space that we got created. This is the new space that got created for storing additional objects till we reach end. We can continue expanding this array as well. So I hope you get the idea behind my plan of implementation and keeping track of the student objects. So let's do that. So we allocate one student object, and if it is returning null, because we know get student data returns null if end of file is reached. So we say if ps equals to null, we simply break out of the loop. Okay. Otherwise, we will have one allocation done for student star star, right? So let's say we define the buffer size, um, hash define the buffer size or chunk size. Chunk has, let's say, 5. Okay. And To begin with, we'll have a student star star p array equals to student star star malloc size of student. What is the type of the elements of that array? Student pointers. So student pointers. And how many such elements we need? Chunk size. So this is our initial chunk of 5 pointer arrays. So after every read, if it is not null, we will store p array. We need an index. So let's say student count equals to ps. So we just simply store that pointer so that we don't lose it. So we have student counter. So int, it should be unsigned int, student count equals to 0. And when we read the data and it is not null, we increment the count. So the student count becomes 1 after we store the first ps returned by get student data into p array, and so on. But the only thing we need to do is reallocate in case the student count increases more than chunk, right? So if we are exhausting our chunk, so that means student count percent chunk means if it is in um, the size of the student, I mean the count of the students is 5 or any multiple of 5, that means we need to reallocate the p array. So we will reallocate the p array using realloc function. Realloc what? We want to realloc p array only, but what will be the size? So size of student star, that is true, but how many we need? Into, we need one more than the division that we get from student count divided by chunk plus 1. So this is the division we need, and this is the number multiple for 5, and we need to multiply the chunk with this number. So these many multiples of chunks we need. So if the student count is 5, we increment student count 5 divided by 5 is 1. We increment it to 2, and chunk is 5, so 5 into 2 is 10. So next reallocation happens with accommodation with the space available for 10 students. When the student count reaches 10, 10 divided by chunk 5 is 2, 2 plus 1 is 3, 3 into 5 is 15. So now the next reallocation happens for this pointer array with 15 capacity, and so on and so forth. All right, so this gets allocated, and we probably are missing one. We were missing semicolon. And then once we are done with this, we just simply display the data. So let's say display students data, and we pass on p array. As also we need to tell how many students are there, so student count, and we implement this function void display student data student star star p array and unsigned int count. Display students data. Now what we do is simply for int I equals to 0, I less than count plus plus I, and we simply do a printf percent ld space percent s, name of the student, and percent 1.1 f for the CGPA, and we say p array I. So this becomes the pointer to ith object. So I equal to 0 means first object. For the first object, we print first the ID, then p array I name, and p array I CGP, and we can add one new line over here. So let's try it out now. We are good at completing this scenario. We are almost there, but one important aspect is remaining. Before I come to that, we will just try to see if it works as we expect it to. So it opens the file, allocates the chunk, reads the data. So first data is Shelly Boris, and we put it in the array, and chunk is, oh, we need to, sorry, I missed the equals to sign here. It should be 0. So we go back here, and it should not be that. So it comes out, reads the second data, and we store it, and so on. So after fifth student, so student count 4. So now student count is 5. So before we are reallocated, and we just continue reading it. Now I guess it is null. So we display the data, and we just let it run, and we will see. Oh, so let's run once more. So we can see that the output is there with 8 student objects. So last is Rosemary with 7.7 CGPA, which is fine. So it reads from file correctly and displays it. What is it that we are missing now? So at the end of the program, or when we don't need the memory that we have got ourselves got allocated on the heap, we need to free that memory. So how do we free this memory? So let's go back to the diagram that we have drawn. Now these all pointers are actually pointing to objects, and each object, for example, is the first object we take. The name is also getting allocated a memory on the heap. So what we need to do is we need to move in this direction. So first we free this memory, then we move to here, free this memory, and then we move and free this pointer. Sorry. Then once we are done with freeing up all these objects that we have allocated, then we free this memory. So first step, second step, and third step. This is how we need to free the memory. If we don't do this way, then we will end up losing some memory. If we directly delete all the pointers that are there in this student array, we'll leak the memory allocated in the names, right? So you get the idea. So let's do that. So first we will free the memory in a loop for the name fields of the structure pointers, the student structure pointers, and then the pointer array itself. So for int I equals 0, I less than student count, so we need to iterate to go to each of the object, student object. So therefore we need it in a loop. P array I and name. First we free the name of that object, and then we free that particular object itself. And this loop then will free every student structure that we allocated on heap, and finally we will free the array that is basically on heap, the pointer of student structures. So this way we are going to free actually all of the memory that we allocated safely. We can quickly run it. The output will be same, but this time we are freeing the memory that we got allocated. So this completes the exercise that is for this part, where we have used pointers, pointer to pointers, and the concepts of dynamic memory allocation and how do we manage such memory. I hope that this was useful for you to understand things. You should surely do it on your own as well. Probably you can pause the videos as you rewatch it and practice it. I will think if you are able to do it, do the whole exercise on your own and also draw the memory diagram after each step of memory allocation happens in the program. What is the state of that memory? How the picture is that you see about the memory. If you are able to do all this exercise, the purpose of this video is served. So good luck for that and thank you very much.